Okay, so those values are in. I'm going to hit the magnifying glass to zoom in on my values. In the assignment, it asks for us to first to write a linear regression model. So I'm going to click on my linear regression and bam, here's the linear regression model. If you click, they also add this feature called the export feature. If you click it, it moves it down for you and you can clearly see your linear regression model. Yes. So to get to the input, you choose your regression. They added the export feature. You click it, and there's your function. Okay. So on your paper, it says, what is your linear regression model? Well, here it is. So now you have your linear regression model. And now, of course, that's not the whole purpose, right? The whole purpose of finding this is to be able to use it, to apply it to other situations. So we're starting off with an easy one, such as linear. But now that you have it, we're now going to go on to the next part of it where it says, what does it want us to do with this linear regression? Okay, so I have my linear regression model, right? And now it says using your linear regression model from part A, what is the predicted weight in kilograms of the body when it's, can't see, 10 weeks old, right? So if you were in the handheld, you would be able to write Y1 of 10, right? But we're not in the handheld. And in Desmos, in order to be able to do that feature, you would have to, I'm going to go back to this. So in Desmos, in order to be able to use the function notation feature, you see how we exported our Y? You simply have to just change it to f of x. And if you change it to f of x, now you can do f of 10 or f of whatever you may need, and it'll do the same thing. Okay? Questions, comments, concerns thus far? Make sense? All right. So that's that part. The next part, so we found out the baby weighs, what is it? 5.395. So I'm going to write down 5.395. Where's my pen? So we got, okay, it doesn't want me to write, but pretend that I could write. The answer's right there. Okay? All right, so do we see the difference of how to find that using function notation in Desmos? All right, next it says the weight of the baby is 5.3 kilograms. Using the model from part A, what is the age in weeks? Okay, so on this part, what tends to happen or what it's asking you to do is to find your Y value, right? So it's giving me my Y. So we have Y equals 5.3. Okay, our equation is what? What's my equation? What equation did we get? Huh? What's our equation? Okay, 0.185x plus what? 3.545. That's it. You just say it with confidence. That's all. So it's giving you your Y and it's asking for what X value would make this, right? This is a linear equation. You could simply solve this by subtracting and dividing. Okay. Yes, 100% doable, right? If you choose not to do it that way, you choose to use technology because you're like, this is a calculated problem. I'm going to use technology. Then using technology, you're going to put in Y equals 5.3. And you're going to find its intersection. And where does Y equal 5.3? Well, it equals at 3.4. I can't see from here. 9.48 something. We're going to say 9.4. Does that make sense? Is that doable? So X equals 9.4 what? 8? 8? Yes. Or 6? 9.4? 486. Okay. And this is in weeks. That says weeks. Go with it. All right. How do you feel? I surely can. So when they give me my Y value and I already have my model, my job is to just figure out where my Y value hits my model if I don't want to solve it by hand. But again, by hand, what were you doing? Subtracting and dividing. So it's not like it was going to be a terrible problem to solve by hand. But if you're allowed to use the calculator, go for it. If not, then you would have subtracted and divided and called it a day. All right, questions thus far about the basics. So how do we know? Well, we know by a couple of reasons. So while some problems will indicate what model you're using, what you're looking for between linear, quadratic, cubic would be a linear is going to be a constant rate of change, like I per something, right? Per, each. Those are things that are letting me know it's linear. Your quadratic is going to be roughly linear rates of change, okay? Meaning that I am multiplying and or adding on to something, right? I am multiplying and or adding on to something. That's why it's a linear rate of change. That second difference value, right? Roughly the same. And then your cubic model, anytime that we're talking about volume, that's going to be cubic, okay? Cubic units, think about that. Same thing with quadratic square units. Anytime you're talking about area, that's going to be a quadratic model, quadratic example, okay? So on example 2, it says here, on example 2, notice that we're not given a table. Oh no, what do I do? You read and try to make a table. That's what you do. That is what you do, okay? So it says here, balloons are filled with water preparation for an epic water balloon battle. Each water balloon is roughly spherical. The radius of each water balloon is measured relative to the amount of water it holds, okay? So what would be the best model of this? I'm talking about something 3D holding liquid. Cubic, why is that? It's volume. We are referring to volume. Okay, because we are talking about a 3D and we're holding space or holding anything, holding an amount of something. That means that we're looking at the volume. Okay, we're going to be looking at the volume, which means that we're going to be ideally working with a cubic model. Make sense? Okay. As you can see, I no longer have any information for my presentation, so we're just going to write directly into the PDF. You know? All right. What next model would I have here? So we're identifying our models. So what would this guy be? And why is it linear? Okay, so your y increases as your x increases, sort of. But the main thing is that it's increasing by the same amount, right? To get from one y value to the next, there's a constant rate of change. Okay. So this would be a linear model. Okay. Continuing. What about C? Why do we say quadratic? This is circular. You're looking at the area of a circle, right? So we're looking at the circular radius. So our key here feature is area, which means that we're going to be quadratic. Okay. So these would be the beginning of the problems that they would give you, and then they would give you something that describes that pattern, right? They'll give you an actual value of the radius, or they'll give you the actual value of the, well, diameter or something, so that now you can build a table to find the pattern to create a function. Does that make sense? But the number one goal for you first is to identify what am I looking at? Make sense? And then to follow the pattern from there. If it's volume or quadratic, you are expected to know like your basic volume and quadratic formulas. Okay. All right. So up next, how do you tell just from a table? Well, because you're using Desmos, you have a couple options here. You can look at the pattern, how it graphs. When you zoom in, you can go over and try to, okay, I see an increase, I see a decrease. What do you see happening naturally to your function, right? So there's a couple things, depending on how quickly you recognize patterns, you want to approach it. But the main number one thing is just put it in the calculator. Put in and analyze what's happening on the graph, okay? So that's what we're going to do. We're going to go to our, I'm going to pull this so that I can look at my table while doing it. I'm going to hit refresh because that's literally how you clear this, is just refresh. I'm going to add table, and I'm going to put in my values. So I have x's are 0, 4/10, 9/10, 1 and 2/10. I'm going to tell you that if you are actually never practicing putting in a regression model, and the first time you put in a full regression model on your own is during a test, you have set yourself up for failure. And I say that because you'll learn the little mistakes you make. You'll learn to double check yourself. But if you're waiting till an actual test to actually try it on your own, you are not setting yourself up for success. Okay. All right. So now that I have my points in, I'm going to adjust my window. Thanks to all the lovely updates of Desmos, to adjust your window, you just press this little guy. The little magnifying glass. So like before, they put this feature here now, and you just hit it, and it'll auto adjust for you. Yeah. I know. They're like, oh, we want y'all to do real well, I guess. So you can't be like, oh, on the calculator section, guys, please don't do terrible. They're setting you up for success. You just got to remember the stuff in the calculator. All right, looking at it, what do I have? A quadratic. So when I go to my handy little regression tool, clearly that one's terrible, but I can see that it is a quadratic. So it asks, which function best models the data in the table, linear, quadratic, or cubic? It's a quadratic, but it says from the table. I also can describe it from the table is that my values are increasing, and then they get to a point where they are decreasing. So when you look at the table, did you notice that? Yes. So on your table, your values were going, I'm increasing, 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 and then I'm decreasing, decreasing, decreasing. What type of function goes up and then comes down? A quadratic, okay? So however you write it, what is this called? I don't know. Y increases and then decreases. Okay. What is our equation of our regression model? It told us. What is it? Okay. When you're rounding, so one thing Desmond will not do is round for you. Okay. For AP testing, they allow two types of rounding: correct actual rounding to 3 decimal places, or truncating. Okay. What truncating means is that you just say, okay, 1, 2, 3, cut off. That's truncating. So truncating would be taking this, and I said, okay, I'm going to chop off. There we go. I'm going to chop off, and I'm going to chop off. That's truncating. Okay. They will accept that. Does that make sense? So either you round correctly or you just truncate. It doesn't really matter. They're going to accept the answer. All right. So my truncated answer would be, I'm not going to write it, but you can. How do we feel? Easy peasy. All right. So that's that part. So on to the next. Next is analyzing your residuals. Do you guys remember that word from Algebra 2? Residuals. Okay. Our residuals. Can't say you didn't learn it. All right. We're going to rap about it. So I like to call residuals time to wrap. And the reason why I say it's time to wrap, your residual equals your actual minus your predicted. Okay. Your actual is your given from your table, right? That's your given. Your predicted is from your regression. What did your regression give you? And you're finding the difference between those two. Oh, it did that itself. I don't know what happened. you know, this is my first time using this feature. So we're rocking and rolling and seeing where'd it go. Oh, whoa. She's doing weird things. Stop. How do you stop? Oh my God. I didn't do that. It did it itself. I have no clue how. I didn't. It did it itself. Oh, it went crazy. Okay. So again, your actual comes from your given, your P comes from your regression. When I say residual, we're rapping about it. Let's rap about it. Okay. So when we are rapping, that helps us identify whether it's a good model or not. Okay. What did we say about our residual? We want it to be what? We want our residual to be small, right? Because your residual is your error. And do you want a lot of error in life? No, you do not. You want the smallest residual as possible. Okay. So we're going to talk about how Desmos gives you that value of your residual. Okay. So up first here, we have 4, 5, 4.2, all these things, right? So we're going to go ahead and put these into our calculator again. That was from the baby weight, right? I wonder if I could be lazy and go back to it. Let's see. How lazy can I be? Just wanted to see if it'll work. Could I have typed it out by now? Probably. Just let me do it. Let me go through the process. No, it won't. It won't. It didn't work. Work at all. Oh, I did. I didn't just delete, did I? You could have told me that before I started clicking, Piper. All right, what are my numbers? Okay, and then my weights. 4.2. 4.2. Uh-huh. 4.8. 5.1. And what? 5.7. All right, so we're back at our baby weights. And this is what the graph was, right? So I zoomed and here it is. What we're going to be what we're looking for is our actual minus our actual value minus our predicted value. Okay. So our actual values were given to us, and our predicted values were what we got when we made our linear equation. Do y'all remember making our linear equation? Yes. So our linear equation, we went to, found our linear equation. I'm going to hit that. Okay. To get all of your values for this, you're going to turn on the table. Turn on your table by clicking your little gear, and I'm going to turn on my table. I'm going to put in the same values that are here. 4, 5, 6, 8, 12. 4, 5, 6, 8, and 12. So these are my actual, and these are my predicted. Does that make sense? So these are the actual. These are the ones that were given to me. And these are the predicted because they're the ones that I use from my regression model. Are y'all with me? Okay. Uh-huh. Okay. So when it says, what are your actual values? Well, those are my actual values that I just got, right? I'm not going to write them out. We see them. These are from your table. So your actual values come from your given table. Your predicted values come from your regression table. Okay. Your residual is the difference between the two. So your residual is going to be your actual minus your predicted. Okay. And you're finding the difference between between those values. And so based on that difference, you would interpret it by saying, is this a good model? Okay. You want it to be small and as close as to 0 as possible, right? Well, because of the AP test, ultimately, you're going to see that your residual is pretty small. But when we looked at our residual plotting, do y'all remember doing that? Residual plotting. So I'm going to click here And you remember for your residual plotting, it's plotting all those differences for you. So it's already finding those values. Okay. So when you do your residual plotting, if I want to know the residual of 4, I'm going to go to 4 and it'll have the value. The residual of 4 is negative 0.85, right? That's the difference between my actual and my predicted. That's what these values represent. So it automatically will subtract and find those differences for you. You don't actually have both tables. I just wanted you to see both so that you can see that you can do it yourself. So 4.2 minus 2.85, is that not negative 0.85? Yes. You don't need the second table. I wanted you to see that it's going to subtract it for you by pressing that R button now. So it automatically will find the residuals for you. Yes? Yeah. Okay. And then the rest is for you to just interpret. The calculator will do all of that. Your job is just to interpret it. Got it? And that's it.